Welcome to Creative World. In this video, we will solve chapter 3 exercise problem number 3.21. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 3.21. Use nodal analysis to find the value of voltage V0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find voltage across this 1 kilo ohm resistance labeled as V0 with this specific polarity. And we have to use nodal analysis technique. So without wasting time, let's proceed towards the solution of the network. We know that in order to apply nodal analysis on any network, we have to follow some steps. First step includes finding out the maximum number of node voltage equations that can be retrieved from that network. So using this equation, we can find out that figure. In this equation, n represents number of nodes exist in the network. In this network, there are 4 number of nodes, so 4 minus 1 will be equal to 3. Maximum 3 number of node voltage equations can be retrieved from this network. In next step, we have to label all unknown non-reference node voltage. We are considering this node as a reference or ground node. Other 3 non-reference node voltage are labeled as V0, V1 and V2. This V0 is appearing across this 1 kilo ohm resistance with respect of this reference or ground node. So whatever the value of this node voltage will be, same voltage will be appearing across this 1 kilo ohm resistance as well. And we are interested to calculate voltage across this resistance. So our main concerning point for the value of voltage will be this node. In next step, we have to assume all unknown branch currents along with their directions. Now we will apply one by one Kirchoff's current law on these 3 non-reference nodes to find out their node voltage equations. But before doing that, if we observe, there is a voltage source connected to this non-reference node 2 and ground node, which means whatever the value of voltage source will be, same voltage will be appearing on this node 2 with respect of ground node. Right now, negative terminal of this voltage source is connected to node 2 and positive terminal is grounded. So we can say that negative 12 volt will be appearing on this node 2. So the value of voltage V2 will be equal to minus 12 volt, and we don't have to apply Kirchoff's current law on this node because the value of this node voltage is known in the form of this voltage source, that is minus 12 volt. Now we will apply Kirchoff's current law on this node. On this node, 2 currents are entering, I1 and 4 milliampere, while only one current is leaving, that is I3. So entering currents are taken with positive sign and leaving current is taken with negative sign. In next step, we have to replace these 2 currents with their respective equations. Current I1 will be equal to the potential difference of these 2 node voltage divided by the value of resistance. Because the direction of current I1 is from node 2 to node 1, which is indicating that node 2 voltage potential will be higher than node 1. That's why we have subtracted V1 from V2. Here V2 was equal to minus 12 volt. So equation of current I1 will be minus 12 volt minus V1 divided by 2 kilo ohm. Similarly, current I3 will be equal to the potential difference of these 2 node voltage divided by the value of resistance. And because the direction of current I3 is from node 1 to this node, so we will subtract V0 from V1 and divide it with 2 kilo ohm to find out the value of current I3. Now in order to omit all denominator values, we will multiply this equation on both sides with 2 kilo ohm. Product of 2 kilo ohm and 2 kilo ohm in denominator will cancel out with each other. Only minus 12 volt minus V1 will left. Here product of 4 milliampere and 2 kilo ohm will result 8 volt. And here product of 2 kilo ohm will cancel out with 2 kilo ohm in denominator. Only V1 minus V0 will left. Now open these brackets. Minus will multiply with values inside the brackets. It will become minus V1 plus V0, and the sum of plus 8 volt and minus 12 volt will become minus 4 volt. Now add these values together and place minus 4 volt on the other hand side of equal to separate it from variables. The equation will become V0 minus 2V1 equal to 4 volt. We cannot further solve this equation, so leave it for now and label it as equation A. It is the first node voltage equation of this network. Now we will apply Kirchoff's current law on this node. On this node, two currents are entering, I2 and I3, while only one current is leaving. We have to replace these three currents with their respective equations. Current I2 will be equal to the potential difference of these two node voltage divided by the value of resistance. Value of this node voltage is minus 12 volt, so minus 12 volt minus V0 divided by 1 kilo ohm will be equal to I2. Similarly, I3 is equal to V1 minus V0 divided by 2 kilo ohm, while I4 will be equal to V0 divided by 1 kilo ohm. Now in order to omit all denominator values, we will multiply this equation on both sides with 2 kilo ohm. Product of 2 kilo ohm and 1 kilo ohm in denominator will cancel out with each other. Only 2 will left, and that 2 will multiply with minus 12 volt minus V0. Here product of 2 kilo ohm and 2 kilo ohm in denominator will cancel out with each other. Only V1 minus V0 will left. Here product of 2 kilo ohm and 1 kilo ohm in denominator will cancel out with each other. Only 2 will left, and that 2 will multiply with V0. It will become 2V0. Now open these brackets. This 2 will multiply with values inside the brackets. It will become minus 24 volt minus 2V0 plus V1 minus V0 minus 2V0 equal to 0. Now the sum of minus 2V0 minus V0 and minus 2V0 will become minus 5V0. Place this constant value on the other hand side of equal to separate it from variables. The equation will become minus 5V0 plus V1 equal to 24 volt. This is the second node voltage of this network. Up to this point, we have retrieved two node voltage equations from this network. We will try to solve these two equations to find out the value of V0. For that purpose, we will take equation A as it is and will multiply equation B with 2. Product of 2 with this equation B will become minus 10V0 plus 2V1 equal to 48 volt. Now add these two equations together. Minus 2V1 and plus 2V1 will cancel out with each other. Sum of minus 10V0 and V0 will become minus 9V0. On the other hand side of equal, sum of 48 volt and 4 volt will become 52 volt. Now divide on both sides with minus 9 to calculate the value of V0. That will become minus 5.78 volt. So the value of voltage across this 1 kilo ohm resistance in this network is 5.78 volt. This minus sign is indicating that polarity of this voltage given in this scenario is wrong. Actual polarity of voltage across this 1 kilo ohm resistance is opposite to the given polarity. So it was all about chapter 3 exercise problem number 3.21. Thank you. See you again in next video.